Now, please welcome Dr. Anthony Fauci, Director of the National Institute of Allergy and Infectious Diseases. Joining him on stage is Steve Clemens, Editor-at-Large with The Hill.
I do not have a mic that works. Yes, I do. Okay. I guess I would be remiss. I want to tell the audience a little bit about Tony Fauci, about somebody. In Japan, there's a term, living national treasures, and I sort of look at you that way. As a journalist, I should be skeptical of you and, have a lot of distance. But 2 days from now are the 50th anniversary of the Stonewall riots that happened, and the LGBT community was very involved in changing the game as we talk about ecosystem on clinical trials and on looking at communities and drugs, and Tony Fauci changed the game for HIV/AIDS on this some time ago. And I just wanted to reflect on that, because one of our challenges today is look at the ecosystem here of both science and technology and advancement, but the other dimensions of healthcare. And you've been through this once, and what you did on HIV/AIDS and what you continue to do is there. And I'm interested in what lessons you have drawn from what you did in the 1990s in HIV/AIDS and what we still need to be aware of today. And what we can still improve today that we haven't when it comes to drug development and essentially awareness of these broad health issues that we can still fix.
Well, probably one of the most compelling lessons from how we addressed HIV/AIDS in the very early years. So the summer of 1981, when a new disease came that was scary, that seemed to selectively infect a particular subset of our population that was already very much disenfranchised. One of the lessons that we learned is that when you're dealing with a public health emergency, that you got to rethink how you approach it. And in the very beginning, when we were developing drugs and regulating drugs, it was very much a top-down. It was sort of regulatory. The scientists who were doing a really good job, my group included, we're not really appreciating the special needs of the community. And I think the lesson that started off with the gay community, really realizing the strength of their political and community capabilities, started questioning the way the government, scientists, and regulatory authorities were approaching a disease that specifically affected them, as opposed to, we will tell you what's best for you. This is the way a clinical trial is designed. This is the exclusion and inclusion criteria, and let's go do it. So right now, when you think about health, and particularly what I'm involved with mostly is emerging infectious diseases, outbreaks, that you've got to approach an outbreak in the context in which it occurs. And the context that it occurs with the community back in 1980s was something we had never, ever experienced before. And it was only the reaching out to the community that we were able to really be as successful as we are right now.
Well, one of these outbreaks that's happening now, which I find remarkable, is measles.
Yeah.
So how's that going?
It's not. Well, measles is really, the measles situation today in 2019 is very discouraging from so many standpoints, because it's not only important for what it is in and of itself, children who are getting infected unnecessarily, outbreaks in communities, but it really, really augurs poorly for the relationship between the public health and scientific community and the general population. So most people know that measles is a very serious disease. It is the most transmissible virus known to man. There's nothing more transmissible than measles. So if everybody in this room were not immune, if you weren't vaccinated, and a person with measles came into the room and coughed or sneezed, 90% of the people in the room would be infected. Wow. That's completely different from influenza, where you can get on an elevator with somebody who's sneezing and coughing, and there's maybe a 21% chance that you'll get infected. With measles, it would be 90%. Juxtapose that against the fact that the measles vaccine is the most effective vaccine you have available. It's 97% effective if you get the 2 shots of the live attenuated. And yet, due to a combination of misinformation and a general feeling of what I refer to as libertarianism taken to its extreme, that we don't want health authorities, be they civil or government or what have you, to tell us what to do. So in order to approach how we're going to get our arms around measles, measles in 2000 was completely eliminated in this country. Not eradicated, because there's still a lot of measles in the world. 110,000 people a year die generally in the world for measles.
110,000?
Right, 110,000, mostly children in the developing world. And when you confront the anti-vaxxers, and I don't like to use the word confront, because if we start confronting them, we're never going to win them back. But if you try to talk to them, they tell you that measles is not a serious disease, which is completely crazy. 1 out of 10 children get an ear infection, 1 out of 20 get pneumonia, 1 out of 1,000 get encephalitis. And back before there were vaccines, there were 2 to 3 million deaths per year worldwide with measles. And there were about 2 million cases in the United States with about 500 deaths. And yet when I tell people that's the case, I was at a congressional committee, one of many hearings that I testified against, and some of the activists behind me, when I said measles is a serious disease, they were putting signs up behind me, "He's a liar." Okay.
Yeah. One of the things I'm fascinated by, in the world, you and I did a talk a couple of years ago, and PBS had done this series, I think it was called Global Killers, or,
right.
Killers coming at us, or something like this, and looking at the global pandemics, influenza, but there was a 3-part series, and some of you may have seen it, and we talked about that, and I thought you were going to lighten things up, and you actually were much more depressing, the more we got into that. And I'm interested in, as we look at these viruses or certain pathogens that are waiting out there that may become unleashed, how prepared are we? What do we need to be doing? And are incentives in the right place so that we can deal with them? Because you've convinced me that we're not where we need to be.
No, we're not. So I think the thing that is interesting, from a societal and psychiatric standpoint about how you respond to outbreaks. So the reality is there have always been outbreaks. Some of them have been curiosities, little blips of things, and some have been public health transforming. They have always occurred. They're occurring right now. Ebola, Zika, West Nile, chikungunya, they happen. And they will occur long after you and I are gone. So the question is, you don't want to frighten society and saying at any given moment, something is going to come in and destroy society. Because when you hear that over and over again, and it doesn't happen, and it won't happen, so don't worry. The fact is, people get inured to that, and they say, well, you're just trying to frighten us. The way you prepare for an outbreak is to preemptively put in place the scientific and public health capabilities to respond. Don't try to guess what the next outbreak is, because you're almost always going to guess wrong. Try to put a fundamental system in place of surveillance. There's a thing called the Global Health Security Network,
right,
where you have the ability throughout the world of people and agencies talking to each other, get point-of-care diagnostics, and really invigorate the field of vaccinology to get vaccines where you don't have to wait 6 to 8 months to get a vaccine when you identify. And right now, with the technologies that we have, what we call platform technologies for vaccines, you can set up the ability to respond like that to an outbreak. I mean, the idea of growing a virus the way we do antiquatedly right now with influenza every year in eggs just doesn't work for an outbreak. I mean, the classic example of that, Steve, was in 2009. We knew in April of 2009 that we were going to have an epidemic, the famous 2009 pandemic of the 21st century. We had 6 months to make the vaccine. And we thought we were going to have it in time. The only trouble is, instead of it peaking in December, it peaked in September when the kids came back to school. And that just is unacceptable and should never happen again.
What do you need to do to get those platform technologies there? Because my understanding is that there's work that folks are trying to create a global commons in doing fast action, genetically based responses on this, but the United States has been a laggard, if you will, in joining that?
No, not necessarily. I have to disagree with you
Okay.
on that. So you may be talking about the Global Health Security
Right.
Network,
Right.
where everybody's connected, particularly in a surveillance and identification. But when you're talking about platform technology, to be able to have a way to make a vaccine that you can commonly apply to virtually any outbreak, whether that is, Zika in Brazil
Right.
or the flu in the United States, I would say the United States scientifically is way ahead of everybody else on that, actually.
And so we're part of that game.
Oh, absolutely.
So
Absolutely.
with Ebola, and let me again back to the business. You were very active and with the Ebola virus, which could have been, if we hadn't had the success we had there, hadn't achieved this. You might want to share with the audience a little bit about how that evolved and rolled out in terms of what was good, but the potential for a massive disaster was much higher with Ebola.
Right.
But as I understand it, we were somewhat lucky that that one of the things that isn't understood necessarily is the business of creating that vaccine. There are not a lot of people with Ebola. You don't have a lot of scale out there, and so there's a tension, as I understand it, between the business of creating these vaccines and particularly in these rarer cases and getting this right. So what do we do when there's a small case, but it has, potentially gargantuan effects?
So that's really one of the really good arguments for the federal government, because pharmaceutical companies are not going to take a major risk to develop an intervention for something that is just not going to be an economic boon for them. So that doesn't mean they will never get involved, but if you look at how much it costs to go from a realization of a concept, there is this microbe here, to the point you're going to have a therapy or a vaccine, an investment ranges from $700 million to $1 billion. A company's not going to do that unless they perceive there will be some sort of economic benefit for them. What the federal government does, and what we've done with Ebola, with Zika, with West Nile, is that the government does what we call de-risking. So if you look at the process of developing an intervention, from the concept, preclinical, early clinical trials, advanced clinical trials, and product, that if you could push the envelope a little bit more this way so that the company doesn't have to take all the risk, and you get it to the point where you look like it actually is going to work, and then you give it over to a company and let them do it. Then you'll get the company involved. But if you sit back and wait for a company to say, oh, Ebola, that's really very, very important, why don't I invest $1 billion? Then they're just not going to do that. And that's what happened with the vaccines for Zika and the vaccine that we're using now in Ebola. Scientists developed it, the NIH and others did the clinical trials, and now it's being used in the Democratic Republic of the Congo.
You discussed HIV/AIDS a minute ago, and I know you have concerns about HIV/AIDS still in the United States. It's remarkable given the fact that we've achieved so much and wiped out so much. And we've even had, we have a common friend, Mark Dybul, who was President Bush's first global AIDS czar. And you can look at Africa and many places of Africa, and the behaviors and applications there have surpassed some communities in the United States. So what's going on?
Well, a few things. What we are now, where we are right now with HIV/AIDS, is something that is really occupying a lot of my time and relates not only to the PEPFAR program that we put together, that Mark and I developed and the president actually mandated. This was the great gift of President George W. Bush, is the PEPFAR program, which has already saved 15 million lives in the developing world. But where we are right now in 2019 with HIV/AIDS is a combination of breathtaking scientific advances juxtaposed against poor implementation. So in the United States, we have drugs now. I think some people in the audience appreciate that, but the drugs that we have now for HIV, if you put a person on an antiretroviral combination of drugs who's infected and bring down the virus to below detectable level, not only will you save the life of that person, you will make it impossible for that person to transmit the virus to somebody else. Just hold on to that for a second. Then you have what's called pre-exposure prophylaxis. If you are at risk but uninfected, and you take 1 pill a day of Truvada, which is 2 drugs, you decrease by 97% the possibility that you will acquire HIV infection. So if you put those two things together, if you think about it for a second, theoretically, if you put all or most of the people who are infected on therapy and you give pre-exposure prophylaxis for those at risk, you could stop the epidemic tomorrow. So it goes, despite the fact that a vaccine would be the nail in the coffin, but we don't have a vaccine yet. Right now, we have the tools to completely end the epidemic in the United States and globally if we needed to. But, that's a theoretical issue. There's a big difference between theory and reality. And the reality is being able to implement. In the United States, we have 38,000 new infections each year. I told you that outside. It's an extraordinary number, which is the reason why Bob Redfield, who's the director of the CDC, and I presented to the department this plan to end the epidemic in the United States, which the president announced at the State of the Union address. And in the United States, we have 38,000 new infections, but there are demographically and geographically concentrated in a way that you could really get your arms around it. 13% of the population in the United States is African American. More than about 50% of the new infections are among African Americans. 65% among men who have sex with men, transgender women, and others. 75% of them among young people. So that's a demographic hotspot. If you look at the map of the United States, I didn't believe it when I first saw it, but I delved into it and it's true. In the United States, there are 3,007 counties. 3,007, all these little boxes on the map. 50% of all the new infections in the United States occur in 48 out of 3,007 of those counties, plus the District of Columbia and San Juan, Puerto Rico. So now you say to yourself, wait a minute, we have the tools to have the epidemic. We know where at least 50% of it is. We really need to put a very aggressive implementation problem. And that's what the plan is all about. So when I was telling you outside, Steve, that I'm still frustrated, I'm frustrated because we have the tools and we just need to implement them, not only in the United States, but globally. PEPFAR did a very good job of doing that, but we still have a ways to go.
With the president's embrace of this in the State of the Union, why is implementation not happening?
Well, he only did it a couple of months ago.
Okay, so, well, right. Once you things move, you move it along. I'm interested in what Tony Fauci's nightmares are. What are the things that we're not talking about that we really need to be?
Well, I mean, I get asked that question constantly, and the answer doesn't really change.
I thought it was a very original question.
Yeah. The answer doesn't change, and that is, as an infectious disease public health person, I mean, there are a lot of other things in society that I worry about, but you don't want my opinion of that. Let's talk about infectious diseases. Yeah. Is a respiratory-borne illness that spreads rapidly, that's new. Namely, there's no background immunity in the population. And that almost always turns out to be a brand new pandemic influenza. Because we know historically it has occurred. It has killed many, many people. In 1918, we keep going back to that, it killed 50 to 100 million people. It is conceivable that that could happen again. And that's the reason why we need to stay prepared for what you were alluding to, that global health security network, platform technologies to develop better vaccines. But I do worry about that because when you have a respiratory illness that easily spreads and has a high degree of morbidity and some degree of mortality, you could have a public health catastrophe. People worry like crazy, if I might use that terminology, about Ebola in the United States. We will not have a major outbreak of Ebola in the United States because in order to get, I've taken care of Ebola patients. In order to get infected with Ebola, you have to come into direct contact with the bodily fluid, no euphemisms, urine, feces, blood, respiratory, of someone who's desperately ill. You don't get it by walking past someone who's incubating Ebola. So the idea of a 1 million outbreak of Ebola in the United States is a non-starter. It's just not going to happen. Yet you might remember back in the Ebola in 2014-15 when one person came to the country and in a hospital setting infected 2 nurses, one of whom I took care of. The country was in a panic. I mean, it was really in a panic. I was getting calls, can I get on a plane? I'm in San Francisco. This person was in Texas. Is it okay for me to get on a plane?
And you're saying worry about measles. Worry about measles.
I'm saying vaccinate
measles.
your children.
Yeah.
Right?
I want to go to the audience in a minute, but let me ask you one of the other questions we've been struggling with today, and it's in something I've been thinking about. I've known you since the 90s, I think, and the question of like the state of science, whether the ecosystem, whether our investments in things like NIH are where they should be. And I don't know if you can even self-advocate for what's going on. But
I'm happy to do that.
What's happening with university research, what's happening with the corporate sector, I'm just wondering, compared to what we used to do, when I used to work for Jeff Bingham in the science, we used to look at science broadly, and you had the sense that we just were clearly in declining investment in basic R&D. And I'm just wondering today whether it's eroding support for the benefits and for the deliverables that have come from science and continuing to invest in it.
Well, given the opportunities today in 2019 in science, although like the NIH, which is my organization, we have a hefty budget. We have about a $40 billion budget. But the growth of that enterprise has been flat for a while and only recently has gone up a bit. If you compare us to where we were in the 60s and the 70s compared to China, India, and other countries, we were in a different galaxy above them. Right now, as we are staying flat and maybe even going a little down, they are coming up. So we are losing ground. I'm not saying that we're being starved, but we're not able to address and grasp the scientific opportunities that are there if we had more resources.
Ed Markey has said we need to double NIH's budget. What would we get for that?
You would get some of the things that we've already gotten from the previous doubling of the NIH budget from 1998 to 2003. Cancer deaths are down. Deaths from certain infectious diseases are down. We have new treatments of immunotherapy for different types of cancers. We have much better ability to manipulate the immune response in certain types of disease. We have a lot of advances. Yeah.
Let me take a question out here. He's right here. You just about jumped out of your chair. I hope it's a good question. Hi.
Karen Lewis Young, member of the Maryland General Assembly and also a member of the Health Committee. Vector-borne diseases are on the rise, particularly Lyme disease in this region. And with the longhorn Asian tick in 9 states, Lyme is growing exponentially. Hopkins recently came out with a study demonstrating that Lyme will remain after 90 days of treatment. So my question is, what kind of research investment is going into Lyme disease, the treatment, other than the vaccine that's being worked on, which is preventative? It won't help those currently infected, and it's 5 years down the road.
Thank you.
Yeah,
Tony?
so I totally agree with in fact, I wrote a recent paper in the New England Journal on just that, the threat of increasing tick-borne diseases. You're right, there is a considerable amount of work now on not only tick-borne diseases in general, but the particularly problematic issue with Lyme. When you talk about residual 90 days, it's not an organism that's replication competent. It's fragments of the organism that can induce inflammation, the paper you're referring to. There's a big difference. And the reason is difference is that antibiotic therapy doesn't help that. If it did, then you would be in reasonably good shape. So there are remnants of the microbe that are inducing inflammation, the paper you're referring to that just came out. We're studying that. But Steve, it's very interesting. This is an example of a question you asked 5 minutes ago, is why don't we have companies come in and put a major investment in developing a Lyme vaccine? They're not going to do that. They developed a reasonably good Lyme vaccine, and for a variety of reasons, it wasn't used, and they pulled the plug. They said, this is crazy. We're not making anything on this. So right now, we're starting from scratch, namely doing the fundamental concept, preclinical and other, to develop a vaccine. But we do need to address vector-borne, particularly tick-borne diseases more than we are.
Well, we'll have to leave it there. You know, oftentimes in Washington, we thank people for their service, but today we really mean it. So,
thank you.
Dr. Anthony Fauci, Director of the National Institute of Allergies and Infectious Diseases, thank you so much.